introduction, we say that folding involves the bending and warping of rock layers in the earth crust due to tectonic forces, primarily compressional stress. This process results in various fold structures such as anticlines, synclines, and monoclines. These structures offer insight into the Earth's tectonic history and are critical in areas like petroleum, geology, earthquake studies, and landscape development. We have an image of showing different types of faults. We have an symmetrical fold, asymmetrical fold, overfold, recurrent fold, and isoclinal fold. Our topic objective is that by the end of this lesson, we should be able to define and explain the concept of folding in geological terms, identify and describe different types of fold, including anticlines, synclines, and monoclines. And number three is that we should be able to analyze the process that lead to folding and types of stress involved. We should also be able to assess the implications of folding on the landscape and human activities such as resource exploration and construction. Welcome. Uh, and Folding, we say that folding is the process in which crustal rocks are distorted by compressional forces by being caused to bend upwards and downwards. And it occurs on fairly young sedimentary rocks. We have the parts of our fold, we have the limb, and we have the axis at this lower end, we have the trough. The trough is U-shaped, we have the crest, we have the anticline, and the syncline. I talk about the anticlines. These are the upfold or parts of the earth surface which bend upwards when folding occurs. While the synclines, they are also called the downfolds, and these are the parts of the earth surface which bend downwards when folding occurs. You have the crest, that is the uppermost part of anticline. You have the trough, the lowest part of a syncline. You have the limb, that is the rock layers sloping on both sides of a fold. Axis, it is an imaginary line drawn vertically through the center of the anticline. We have the types of fold. Number one is simple symmetry fold, and here is the image. You have the limb here, the axis, and you draw the axis. It is vertical. You have the limb, which are symmetrical about the anticline. This is the anticline. They are symmetrical about the anticline, formed by two compressional forces of equal magnitude. The compressional forces at this end and at this end are equal, so leading to formation of a symmetrical fold. A symmetrical fold, the limb, you have the limb, the axis, and which are asymmetrical about the anticline axis, or in which one limb is steeper than the other. And they are formed by two compressional forces of unequal magnitude in which one is stronger than the other. And now I'm going to discuss about the overfold. And here is the image of the overfold. And we have the isoclinical folds. And you have the vertical isoclinal folds and the inclined isoclinal folds, which are packed closely together with limbs almost parallel to each other. Vertical isoclinal folds are formed by compressional forces of equal magnitude, with inclined isoclinal folds are formed by forces of unequal magnitude. You have the recurrent folds, and here is the image of the recurrent folds. They lie in a horizontal manner, and they are formed by two compressional forces, one of which is very strong. You have the network over thrust fold, in which one limb is pushed over the other limb. The forces are very strong, and they cause a fracture or fold to develop. Anticlinorium. You have the anticlinorium and the synclinorium. Folds characterized by minor upfold and minor downfolds. And land is first subjected to weak compressional forces, resulting into minor folds. Later, the land is subjected to much greater compressional forces, resulting into new upfalls with minor falls, that is the anticlinorium, and a new downfalls with minor falls, the synclinorium.